Welcome to our exciting journey into one of the most intricate yet powerful parts of the Google Cloud Networking Suite, Private Service Connect. We're in for a thrilling adventure, so let's get started. On one side, we have the service producer. This could be you, a colleague from a different team, or even an external organization. They're putting up some sort of valuable service. A load balancer is then employed and connected to Private Service Connect. But what's a show without an audience? That's where the service consumers come in. They're the clients enjoying the service safely through a Private Service Connect endpoint. To make sure everything is as secure as possible, we're using completely private networking. Now, let's set the stage for our performance. We're starting with a fresh new project. Our opening act takes place in the Compute Engine service, where we'll set up our web service. For this demonstration, we'll use Apache as our web server. But remember, the possibilities are endless. You could use any type of service, even something that's not HTTP based. The first thing we need to do is adjust the network settings for our test virtual machine VM. We'll turn off the external IPv4 address. Don't worry about SSH access or load balancer health checks. The default firewall rules will take care of those for us. Let's take a quick look behind the scenes at these default firewall rules. We can see that internal communication and SSH access are already set up. But wait, we should also add load balancer health checks to our performance. We'll do this by adding it as a network tag to our VM. Now comes an important plot twist. We're setting up a private VM without a public IP address. This means we need to introduce another character to our story, CloudNet. CloudNet will help us download the Apache Web Server library and other necessary tools. After we set up CloudNet and configure the router settings to match our VM's location, we should be able to install the Apache Web Server. For a bit of flair, we'll also customize the HTML page it serves. Great, now we have a fantastic test service ready for the spotlight. But our story isn't over yet. To enable Private Service Connect, we need to put a load balancer in front of our service. So let's get that set up next. Before we set up our load balancer, let's take a quick look at the Private Service Connect page to remind ourselves what types of load balancers we can use. For our setup today, we'll use a simple yet elegant option, the pass-through network load balancer. It's perfect for our needs. However, we need to take a small detour. To use our load balancer, we need a backend instance group. Let's quickly set that up. Finally, our instance group makes its grand entrance. Now we can complete the load balancer setup. Since we're dealing with an HTTP service, we'll use the TCP protocol. A simple TCP health check should be sufficient. No need for complex configurations here. For the front end of our load balancer, we'll use an internal IP address and open up port 80. With these settings in place, we're ready to create our load balancer. Once the load balancer is set up, we want to make sure our backends are healthy. We can see our VM instance is up and running. Let's double check that the health checks are working properly. If after refreshing a few times we still don't see a healthy status, we might need to look at our firewall rules. We need to make sure port 80 is open so the health checks can get through. I thought we had allowed load balancer health checks on the VM, and it looks like that's the case in the firewall policies, but I don't actually see it listed. To solve this, let's take matters into our own hands and manually create the load balancer firewall rules. We'll grab the IP ranges for our load balancer health checks and add them as firewall policies. Great, this seems to have done the trick. We now have a healthy backend and our load balancer will direct traffic to our instances. Now it's time to introduce the star of our show, Private Service Connect itself. We've set up everything else, and now we're ready for the final piece of the puzzle. To demonstrate how Private Service Connect works, we're going to set up a second team. This will be our service consumer. Let's start by creating a virtual private cloud or VPC network. We'll use automatic subnets and allow all the default rules. Once our new VPC is ready, we can create a test client VM. We'll change its network settings to use our new consumer network and remove its external IPv4 address. We're doing this to clearly show that we're using internal networking only. While our client VM is spinning up, let's go to the Private Service Connect section and set up the final pieces. We're going to create what's called a published service endpoint. We need to specify the target service, which we can find by going to our published services and copying the long ID for the service we set up earlier. Our endpoint will live in the consumer's network, so we need to reserve a subnet for it. Let's go to our consumer VPC and create a new subnet specifically for Private Service Connect. Now that we have our subnet set up, we can finish creating our Private Service Connect endpoint. We'll choose our newly created subnet and assign an IP address for the endpoint. It's worth noting that while we're keeping everything in the same region, US Central 1, for this demonstration, you can actually set up Private Service Connect across multiple regions or even globally. This flexibility allows you to design your network architecture to best suit your needs. Now comes the exciting part. Let's test our setup. Remember, our client VM is in a completely different VPC, the consumer network, and normally wouldn't be able to reach our published service. But thanks to Private Service Connect, we can make it happen. Let's SSH into our client VM and try to access the server using the IP address we assigned to our Private Service Connect endpoint. And success! We're hitting the server. This means our Private Service Connect is working as intended, allowing secure communication between our separate networks. However, it looks like we might have accidentally removed the index.html file from our web server during our earlier tinkering. No worries, let's quickly recreate it. After adding a simple HTML file, we can test again and perfect. We're successfully reaching our service through Private Service Connect. As always, we'll provide the diagram illustrating this setup in the video description, along with a link to the diagramming tool which you can use via a free trial. We'll keep an eye on the comment section for any questions and want to thank you for watching. Please enjoy responsibly.